What if a car could see pedestrians and stop automatically? What if a drone could scan a field and detect where crops are dying? That's the power of computer vision. It gives machines the ability to see, interpret, and make decisions based on visual data. AI's eyes are wide open. Let's find out how they work. What is computer vision? Computer vision is a field of artificial intelligence that trains computers to analyze and understand images and videos, just like humans do. While humans use eyes and brains, machines use cameras to capture images, algorithms to process them, neural networks to interpret meaning. In short, it's about teaching machines to detect, recognize, track, classify, and react to what they see. How does a computer see? Machines see pixels, tiny color values made of RGB, red, green, blue. For a human, an image of a cat means cute and fluffy. For a machine, it's just a giant matrix of numbers. Like this. Sharp copy edit, 255, 230, 190. Pixel 1, 240, 210, 180. Pixel 2. Computer vision uses image processing algorithms and deep learning models to detect patterns in those numbers. Key tasks in computer vision. Let's break down the most common CV tasks. 1. Image classification, assigning a label to an entire image. This is a cat. Used in animal identification, medical imaging, satellite mapping. 2. Object detection, locating and labeling multiple objects in a scene. There's a dog, a bicycle, and a person. Here's where they are. Used in self-driving cars, surveillance. Retail analytics. 3. Object tracking. Following a specific object through a video or live feed. Track that ball throughout the soccer match. Used in sports analysis, security footage, industrial robots. 4. Semantic segmentation, classifying every single pixel of an image. This pixel is sky, that's road, that's a car. Used in medical scans, autonomous navigation, augmented reality. 5. Facial recognition, identifying a person based on facial features. Used for phone unlock, airport security, social media tagging. 6. Pose estimation, detecting body parts and their movement. Used in fitness apps, motion capture. Physical therapy, how computer vision works, behind the scenes. Let's walk through a basic image recognition pipeline. Image input. Upload an image. Pre-processing. Resize, normalize brightness, remove noise. Feature extraction. Identify shapes, edges, patterns. Model prediction. Neural network classifies or detects. Output. Return labels, bounding boxes, or masks. The brains behind this process? Convolutional neural networks, CNNs, the gold standard for visual tasks. Understanding CNNs. The heart of computer vision. CNNs work by applying filters that detect patterns like edges, corners, textures, shapes. Each layer in the CNN captures increasing complexity. Layer 1 detects vertical and horizontal edges. Layer 2 detects shapes like circles or lines. Layer 3 combines shapes to identify objects. Think of CNNs as a team of visual inspectors. Each layer handles a different part of the image. Training these networks requires thousands or millions of images, and GPUs for fast processing. Real-world applications of computer vision. 1. Healthcare, detecting tumors in X-rays and MRIs, analyzing retina scans for diabetes, monitoring surgeries with smart cameras. Self-driving cars, road lane detection, traffic sign reading, pedestrian tracking, hazard prediction. Tesla, Whimo, and other companies rely heavily on computer vision to keep passengers safe. 3. Agriculture, crop health monitoring via drone footage, weed detection, fruit ripeness prediction. 4. Retail and e-commerce smart checkouts, Amazon Go, shelf stock monitoring, visual product search. 5. Manufacturing defect detection in quality control, robotic arms guided by vision, real-time safety monitoring. 6. Security and surveillance, intruder detection, license plate recognition, emotion detection in crowds, image datasets that made CV possible. These public datasets trained the world's best models. ImageNet, 14 million labeled images across 20K categories. COCO, Common Objects in Context, for object detection. Open Images, Google's huge visual dataset. LFW, Labeled Faces in the Wild, for facial recognition. These datasets are like the curriculum that AI learns from. Ethical concerns in computer vision. With great vision comes great responsibility. Here are some ethical issues. Privacy invasion, facial recognition in public spaces without consent. Example: surveillance cameras scanning faces in shopping malls, bias in recognition. Facial recognition systems often have racial and gender bias. Studies have shown higher error rates for dark-skinned individuals, misidentification of women more than men. Why? Because the training data lacked diversity. Deepfakes, AI-generated videos where people say or do things they never did. Used for political manipulation, fraud. Harassment, surveillance, and control, authoritarian regimes using CV to monitor citizens' movements. The line between security and control is getting thinner. How to make CV responsible. Here's how we can build ethical computer vision systems. Train on diverse datasets. Use transparency tools to explain how decisions are made. Let users opt in or opt out of facial detection. Ban facial recognition in sensitive areas. Schools, public spaces. Tech companies, governments, and researchers must work together. The future of computer vision, what's next? 3D vision. Understanding depth, shape, and real-world scale. Neural radiance fields, NeurFs. Reconstructing realistic 3D spaces from photos. Vision language models. Combining visual input with text understanding, like GPT-4 vision. Wearable AI. Glasses. Real-time translation, sign reading, facial recognition. Edge vision. AI. Cameras with built-in AI. No need to send data to the cloud. Soon, CV won't just be on your phone. It will be everywhere. Let's recap what we learned. Computer vision helps machines see and understand the visual world. It uses techniques like image classification, object detection, and face recognition. Real-world applications span healthcare, security, agriculture, self-driving, and more. Ethical concerns include privacy, bias, and misuse, and must be addressed. The future is 3D, multimodal, wearable, and deeply integrated into daily life. In our next module, we'll discuss how AI is impacting our daily lives, from smart homes to smart businesses. Like, subscribe, Future Mind AI Trends, and hit the bell icon. Comment below. Would you be comfortable with facial recognition in your city? Let's continue seeing the world through AI's eyes, one pixel at a time.